Good morning, everybody, thank you, Steve and Jay, for inviting me here to CanBIM. Let's see if my presentation comes up. There it is. Today, the actual speaker for this panel was unfortunately he wasn't able to make it today, Ray Flippiak, but I'm going to sub in for him the best I can, so bear with me. We're going to talk about our Bentley Open Roads technology, integrated civil for information modeling. And again, we want to know what that is you know, we talked about our previous talk about the SIM and BIM. Transportation owners are now requesting, but you know, we got to make sure we understand that BIM is not a product, a solution, data format, or a vendor-owned initiative. Okay, it's not a monolithic 3D model or GIS database. And quite frankly, you know, sorry for the architects in the room, but it's just not about buildings. You know, we kick a fair shade in that. So BIM is a process, and that it has to be understood, embraced by people, and supported by our friends in IT systems as well. We kind of sometimes miss those guys out in the back room, the little computer nerds out there typing away at their machines and the back of it. It has to be adopted and supported by these guys. And BIM cannot be bought. It has to be adopted and it's for successful implementation. So why BIM? We talked about earlier here, optimizes production, models are integrated, information, coordinates design, increase quality, very important, easier to reuse information. And that's something that's key here. You know, you hand over this, you build this infrastructure, it's important that we can be able to reuse it downstream from an owner-operator perspective. Increase design quality, improve design methodology. We want to be able to reduce those change orders. We want to be able to be able to show that design intent, if you want to call it that, and increase quality for build facilities. Some of the benefits of BIM are, efficient manage control costs, reduce risk. Visualizing is key here, as we've seen from previous presentations, the ability to actually look and see how your model and how that infrastructure is going to work. And when we talked about earlier about removing mistakes and improving safety through designing in BIM. And let's see, like I said, Steve, I don't know if this video will work as well, but we'll see. So again, final design capabilities. Open Road technology offers an immersive interaction. We allow you to bring in survey data, mapping, geometric, terrain modeling information, corridor modeling, dynamic cross sections, functional components, civil cells we call them, and again, back to design intent and design time visualization key here. So again, we'll see if this video kind of fires up on its own, or do I have to click here? Let me see here. Oh, no, I don't. Try to go back here. Is there a way of going back? I guess not. All right. Same problem with the video. So basically what this video is looking at our Open Roads product and where we can draw sort of a corridor on the one side here and easily be able to apply what we call a template. And then that template is then moved through the model. As we call it in Bentley, there we go. All right, so now we can talk about opening up the file. We're going to basically select that corridor. We're going to apply template to that line work and be able to move through that and be able to move that template. Those templates can be standardized templates, curb and gutter, center line of road, these kind of things, and the ability to, as we call it. You can work in 2D and you get 3D for free, right? So you're working in a 2D view, you're moving along through this, and it allows you to leverage these templates that you create and you store. And these templates can come from various formats as well. We work with our competitor, or our software vendor partners as well. So now you're seeing the result of that, where the templates move through, the earthworks have changed. We brought in this model, and we've leveraged some LiDAR data, some terrain modeling, and again with the dynamic vertical sections where you can move the vertical cross section up and down and see the results of these kind of what-if scenarios. And this is kind of key to working in a 3D BIM environment, is being able to have that flexibility in a civil side to to change automatically, because things, sometimes the land or the earth doesn't work well, and you want to make the most cost-effective way possible. So another thing is you can do is, if you want, you can just, in our product, you can basically draw your own template as well here. So in a few seconds, we're going to be able to draw an alignment next to there, and just by simply selecting a template cell, we'll move along forward. But you know what? I'm going to probably run out of time here, guys, if I let this thing play through. So you get sort of the gist of the situation. And then we also have something else. We talked about SIM, but Steve, have you heard about BrIM? So how many acronyms can we throw here at this technology? It's endless. So we want to talk about our bridge information modeling and how how we use our tools to design our bridges, and we have, again, talking about our collaborative benefits, the ability to be scalable in our project teams, and understand the information morality and life cycle. Again, we talked about earlier in some of our presenters, the key of maintaining asset management throughout the project. And the key here is to getting that data entered accurately so it can be leveraged from an operations point of view as well. So, one of our sort of our reference accounts, our reference project was the Tappan Zee Bridge in New York State. I'm sure some of you people have heard of that. It goes across the Hudson River up near Terrytown, and it's a joint venture consortium. And it was the playlist for this, we use some of our bridge components, our bridge software. But the key thing is the owner mandated a high level of asset tagging in that information. So every element in that bridge has an asset tag, and it feeds into a database that you then can leverage from an owner-operator perspective, be able to use inspection tools like our InspecTech and our Building Navigator. So again, we talk about design time visualization, again, reducing the cost, and being able to, as well, look at the safety aspect. And let's see about this next video, if it kind of fires up. Here we go. And to be able to go from a LiDAR data, inputting your standard template, pushing through your corridor modeling, and going from there, adding the sort of the street side. All this visualization is done in our Open Roads product. So, you model, you design, and you can generate these kind of visualizations all within the same product using the same data, common format. So you can walk as this model comes to life, you can see sort of the car moving through, and we have this capability all encompassing the same application to be able to add cars, add pathways, speed, and be able to check things of these kind of natures and produce this kind of design time visualization. So, walk through it. So again, Open Roads again is a technology of integrating various file formats and various engineering models, being able to output into our iModel product, which can feed into automated machine guidance with our association with Trimble. We accept in data from AutoCAD and their families, as well as other data formats as well. And the key is we want to be able to work together with them. So again, we're just going to walk through a bit of a quick video here of a bridge that we wanted to add sort of a ramp to. Again, working in our Open Roads application here. So I got about 50 seconds here to go through. So let me see if this thing will fire along. And again, you're basically just picking up sort of symbols. You're gathering that data, gathering that information into the model, and you're seeing these things live. And this is sort of the power of leveraging these kind of tool sets. We can go into our Trimble warehouse, pick up a crane, and just basically add the crane directly into the file. And then based on that position of the crane, we can do several basically, visualizations and clash detections for the swing of the crane from a construction's point of view as well, to make sure that, our roadway or our bridge is not going to have any problems with construction. So I've got about 4 seconds left, so I'm going to just kind of run it through here. We have a thing called iModel for civil construction, where we can take your BIM model, bring it into our iModel format, and that aggregates, it's a schema, it aggregates the information and graphics and that, and ties it into automated machine guidance. And I'm going to, if I can run this through in the background, this talks about a tunnel that was done in South America that we did using some of our tools, and I believe some of our friends from Autodesk tools as well. So I'd like to be able to run this in the background if you can. Okay, thank you. This talks about design visualization at the next level. It takes it to a place that a lot of people want to be, and it's just a fantastic video, so I'll just let it play through. Talks about some of the fabrications. All these were prefabricated on land. You can imagine the detail of the accuracy you needed, and then floated up in a dry dock and then lifted out, and then had to be precisely dropped on the seabed floor. So you can just imagine the ability to visualize this. How could you have ever done this before? To just do it. BIM tools generate this kind of information. And I believe this budget was done on time and this project was done on time and on budget. And they were actually one of our Bentley award winners and your infrastructure in good condition.
Great stuff. Do we have any questions? I think we got a few minutes here.
Hi, it's Ian Trill from Intuitive and CanBim. It looks like you have a lot of municipalities and owners that are fairly advanced and I assume requesting these services. Do you have any cases where you find resistance in certain markets or with certain municipalities, and you have to, like, how do you deal with that? Do you have to sell this technology to them, or are they asking for it, I guess, is the question.
Yeah, I can kind of touch base on that quickly. Yeah, you know, I used to work at the Toronto Transit Commission before I came here to Bentley, and BIM is an obstacle. It's a process that has to be learned. But as you can see from some of the end products, the end games that they can deliver, it's really to take it more to two things. You have to educate the project managers there, because they sort of need to be involved more and more. And then the other thing is to really educate the operations group, you know, to show them how to leverage these models in operation. And that's really where this thing takes off. So I think, Ian, if we're able to do that, I'm sure you're going to see a lot more push and more demand from motor operators. I know that with Tappan Zee Bridge, that's exactly what happened.
Yeah, in the U.S., same thing, but like JP was saying, everybody knows it's a process, and it's going to require a lot of investment in infrastructure, hardware, software, and then also a learning curve. There's no doubt that everybody sees the benefits right now, but it's just how you implement it is the part where the resistance is. And like JP was saying, at the project manager level, I mean, those are people that really want to get the job done. And if you're trying to convince them that they should migrate to a new technology or a new way of delivering a job, then you have to prove it and then be able to deliver. And a lot of it also, it's emerging. It's a moving target. I mean, we're getting a lot of applications every year or every couple of years that you need to keep up with. So as far as my experience, I think this has been the biggest challenge in convincing clients, owners, and designers that this is the path moving forward.
I'd like to add one more thing to that. If you're using and leveraging BIM within your internal workflows, then this is an artifact that just comes along for the ride. And I think that's a key to selling it to the owners, is they get this almost for free. Because you're leveraging BIM, you're using BIM to increase your productivity internally, and then you hand it off to them in this format. That's a great way to start the adoption cycle happening. It's just something that comes along for the ride. You're using it for design, collaboration, analysis, public engagement, and then, oh, by the way, here's the model when we're done with it. And then that starts raising their level of expectations toward the next project. They start thinking about that in their mind, that, hey, you know, I really like the way that last project happened. Let's spec that on the next time.
Turn this on. Anyways, hi, my name is John Ford, Lead Consulting. Just a question, and maybe it's more for Jay. Building these models, you obviously have to take information from innumerable sources. In practice, how easy or difficult is that using one of the platforms or both the platforms, and some of the big stumbling blocks that maybe you've come across, and how you overcome those?
So for those of you that didn't hear, it's just how easy can you aggregate all these different models into one platform? It's not a one-click solution, and there's so many file formats that we deal with. IFC is definitely becoming the norm into converting all these different file formats and bringing them in together, but that's more on the building side. It's not as advanced for the civil components. Land XML and other formats are better for civil at the moment, but I know there's a huge push for IFC. I guess the biggest challenge, other than migrating those files into one platform, is how do you save all the information that's in their native platform. This has been a bit of a challenge for us. But, we follow a methodical process, export a small file, see what comes in, what doesn't, and make sure that it's fixed in the next round of work. The other thing also is getting them to line up in the same coordinate system. When you work on civil jobs, you know that there's a certain coordinate system that you need to be working with, whether it's state plane or any other coordinate system. And then some of the applications dealing with architecture or prefabrication or smaller models don't play well with a model that is at a GIS level. So there's a lot of challenges. We try to the best of our knowledge to put best practices in place and make sure that whenever we're aggregating a model, we're following these practices and not reinventing the wheel every time. So we work a lot on knowledge sharing and make sure that we're all on the same page. Any other questions? I think we're over time, so thank you. Thanks, everyone.